We're almost there in this section of features or characteristics of atoms. We just got 3 more facts to go through, and then in the next video we'll apply it all together and draw atoms completely from scratch. So, first one, every atom wants a full set of electrons in its outermost shell. This is where all the interesting stuff happens in chemistry. This is the reason why materials or chemicals will actually react in the first place, because they want a full set of electrons in its outside shell. What if they're born with too many or too few? They will do whatever it takes, either give away the excess, steal whatever remaining that needs to get, or maybe sometimes it has to share. This is what drives atoms, or elements for that matter, to actually be reactive or unreactive. If an atom has a full set, it's unreactive. It has no motivation to do anything more. It already has it's already achieved its goal in life to get a full set. Whereas some atoms have very few or just 1 or 2 missing, and they become so reactive. This is why it's so important. Every atom wants a full set in its outermost shell. It's so important we give a specific name right to the outside shell, and we call that the valence electron shell. Or sometimes valence shell will do as well. I've got 2 diagrams here. The one on the left, the valence shell is actually the second shell because that one's being used. It's the outermost shell that's being occupied by electrons. I've got another diagram on the other side of my sheet here, and I'm going to point the arrow to the third electron shell, which I know from ahead of time that I will be using that third shell to fill up my diagram later. So that would be my valence shell. If that third shell wasn't being used, let's say I just drew too many rings on it, then I would point to the second shell if that was the outermost shell that's being occupied. Okay, next feature. Electrons will fill these electron shells from the inside, then towards the outside shells. And they do this because the electrons want to be as close as they can to the nucleus. The nucleus is positively charged overall. Think of it, we've got neutrons, which are neutral, makes no difference. And we've got protons in there as well, which are positive. So overall, that nucleus has to be positively charged, very positively charged. And if you're an electron, which is a negative charge, we know the opposite charges attract. They want to get as close as they can be. So when you've got, let's say, 6 electrons and you've got to put it onto your diagram, fill the inside shell first, then work your way to the second shell and then to the third shell and work your way outwards. Last feature, only the number of electrons can be changed for an atom. You can't change the proton count, you can't change the neutron count, but you definitely can change the number of electrons. The reason why you can't change protons and neutrons is because they're very, very strongly bound in the middle of the atom. And unless you're doing some nuclear chemistry where you're either breaking the nucleus apart or fusing 2 nuclei together, you're not going to change those protons and neutron quantities. But in a general chemical reaction, electrons are often given away or stolen from another atom or even shared. So those quantities of electrons can actually be changed. And that often happens during a chemical reaction. Now, let's go back to the diagram here that I haven't quite filled out. I want to fill out this diagram from the inside out. Just like I said before, the electrons will fill from the inside to the outside. And I've done some counting here. I've got 11 blue spots in the middle, which is my protons. I've got 13 black spots in the middle, therefore I've got 13 neutrons. If I go back to the previous videos about atomic number and the fact that atoms are neutrally charged, if I have 11 positive charges in the middle, I must have 11 negative charges in my atom as well. That's how I got my value here, that I must have 11 electrons when I'm done. So I'm going to start assigning the electrons onto my atom now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No more room. Go to the outside shell. There we go. That gives me 11 electrons in total. Now you'll notice that the way that I've put my electrons onto those shells, I've definitely paired them up in certain cases and definitely put them in very definite spaces like the top, left, bottom, and the other side. That is done on purpose because if you pair them up like this, it'll set you up so much better for when you get to grade 11 and 12 chemistry, where things get much more advanced. If you develop good habits now, it makes life a lot easier in the future. You may find on regular bits on the internet, they have all these electrons arranged
evenly spaced apart, that's also acceptable, but less useful when you get to grade 11 and 12 senior chemistry. So I prefer to encourage my students to do it this way. Now, I didn't explain why I'm pairing them up like this. If you want to learn more about it, go check out this other video I've made in the past about electron configurations, which tells you all about this in detail.